Hi, everyone. I'm Joel Susel. I'm the head of product for RevAI. I want to give just some brief background on me, and then I want to tell you about Rev, the company I work for, and how we fit into this equation. So for some brief background on me, I've spent the last 10 years at the companies you see here on the screen. I led mobile product at Dolby, and then went on to be the founder and general manager of Dolby's virtual and augmented reality business. I led enterprise product at a background check company called Checkr. And for the last year, I've been the head of product at RevAI, the developer platform from Rev. So I wanted to talk to you about Rev, introduce what we do, how we fit into the AI ecosystem, and what we've found, some meaningful findings we've uncovered in the realm of mitigating bias in AI. I'm not claiming that we've solved the problem, but we have made some meaningful, positive progress. And I want to share our findings with the industry so that we all can build a more responsible, reliable, and scalable future together. I will point out that I am a white male, and I will be speaking about bias. And white males have not been disproportionately disenfranchised by AI like some other groups have. I'm here today to share some information about our approach, to share some data about how our approach moves us forward, but these are first steps. Our progress is exciting, but there's more to do. I beseech you, we as an industry need to collaborate and commit together to building a sustainable, scalable, and fair solution in our respective industries. So, Rev is a company that started over 10 years ago with a mission to create great work-from-home jobs. It's kind of an interesting mission, partially because the beneficiary of that mission is the worker. It's not the shareholder, it's not the customer. And it also gave us a lot of license to try and build a number of different businesses, which we did. But where we've landed and invested heavily in the last 10 years is in the transcription space. We have our product, Rev.com, that attracts 60,000 freelancers. We call them Revers, who do excellent transcription, captioning, and subtitling for our customers. Part of making a great work-from-home job means really cultivating a sense of rewarding work for these Revers. We have created ways for Revers to level up and earn more money in exchange for doing good work. And so as a result, we are a leader in the space. Our customers are happy. We have a healthy revenue stream. But there's something even more exciting that is a byproduct of our success in the human transcription space. And that is, I'd argue, the best data set in the world for training an AI-based ASR, automatic speech recognition solution. It is a byproduct of us earning money, and so it has we've amassed tremendous hours of high-quality data. It's audio in, expert transcription out. We have millions of hours, and while I'm speaking to you today, we are adding even more hours to that data set. And as a result, our RevAI solution is, we believe, the most accurate in the world. One thing I will say is that, of course, we also use this engine to make our Revers even more efficient. And so there's this circular exchange of value happening between AI and human that happens underneath the hood of everything we do at Rev, and more on that in a second. So, welcome to the AI Summit. Welcome to the Responsible AI track. And we're here to discuss a couple high-level questions. One, why AI needs to be front of mind for business leaders like yourselves. And two, what to do to accelerate the AI journey and the essential considerations that, frankly, need to be addressed in order to do that in a safe and fair way? Well, I have some thoughts and some experiences on both these topics, so let's dive right in. So why does AI need to be front of mind for business leaders? Well, according to Daugherty and Wilson in their book, Human Plus Machine, AI represents the third wave of business transformation as it relates to human empowerment. They posit that wave one was characterized by standardized processes and things like the assembly line that were commercialized at scale by the likes of Henry Ford. The second wave being more automated processes, leveraging technology to build process and workflow automation. And I would characterize this as the 90s, and it's when companies like UPS and Walmart proliferated because of their back office optimization and excellence. So now we are in the third wave, which is characterized by adaptive processes, where real-time data is used instead of an a priori set of steps. It's adaptable. Where the first two waves were characterized largely by machines replacing humans, this third wave is described as mutually complementary interactions between humans and machines. The third wave doesn't replace humans, rather it puts them to work in new and different ways. So Daugherty and Wilson call this the missing middle. If you see on the left, we have human activities. On the right, we have machine-only activities. What's new, what's distinct about this wave is that there is this middle where machines and humans are working seamlessly together to empower both sides of that equation. Machines perform the repetitive tasks, while humans train, improve, and place guardrails around the machines. So this third wave could represent an entirely new industrial revolution with orders of magnitude improvements in efficiency, cost, and scale. It represents tremendous opportunity. I know you believe that because you're here, but it also introduces a new set of challenges. And those challenges come as we place much more decision-making power in the hands of machines, who ironically have no hands. So one of the biggest emotional challenges is related to trust. Trust that the machine is going to do the thing you expect it to do. AI is at a disadvantage here, and some of that mistrust is emotional and some of it is justified. On the emotional side, it turns out humans lose trust in machines more quickly than they do in humans. There's a term called algorithm aversion, and if you've ever clicked 0 or screamed operator into the phone, even if it means waiting an hour, then you have exhibited algorithm aversion. But I'm sure none of the technology elites in this room have ever resorted to Luddite practices like that. Second is that humans are more sympathetic to mistakes made by other humans. Gil Pratt, the chief executive of the Toyota Research Institute, told lawmakers on Capitol Hill in 2017 that people are more inclined to forgive mistakes that humans make than mistakes made by machines. This is also, I called it an emotional reason, but it's also justified. I'll tell you why. It's understandable. Humans make different mistakes than machines do. We know this. We experience it because we operate a human-based transcription service as well as an AI-based transcription service. While both of these services can be measured using something called word error rate, and in fact, that is how they are measured, humans tend to omit words in places that listeners or consumers find acceptable. Times when there are interruptions or there's crosstalk, where perhaps in our brains, we have to do our own filtering. Whereas machines might make a mistake in somewhere that is less confounding and therefore sticks out more. But both of those mistakes show up as just one mistake in the calculation of word error rate. And so our yardstick is a little bit biased, but the main point is that humans and machines do make different mistakes. So we have to build trust, We have to be able to rely on these machines to make rational decisions all the time. And all the time is a very tall order. And one of the biggest reasons for that is the notion of bias, which I'll explain now. So first off, I'll start by saying that every human exhibits bias, to each his or her own, but we all have them. If you look at the picture to the left and envision a call center with thousands of agents, each exhibiting his or her own biases, what you have is actually a very well-diversified, high-variance output as it relates to bias on any specific input. It's expensive and complex, but it is diverse. Now, if you train an algorithm to replace or augment these call center agents, which is depicted on the right, what you get is a scalable, cost-effective solution. But if you're not careful, it won't have that same glorious diversity that you had with thousands of independently biased agents. Whatever bias is present in that algorithm will be applied at scale to all of its inputs. So there are three ways where bias gets introduced into AI systems. Number one, in the input training data set itself. And if it lacks diversity, then you are introducing bias. Number two, the ground truth that is derived from the data. And if that process lacks diversity, then you're introducing bias. And the third is the developer building the product and that developer's inability to analyze performance of their system on anything other than the metrics that they have in their original training set. There's a litany of problems. Let me go through them one by one. Training data, I'll tell you from experience, training data is hard to come by. It has to be large in volume. It needs to be high quality. And you know the old adage, garbage in, garbage out. Well, not surprisingly, in an effort to ship product quickly, we often fixate on how much data is the minimum needed to ship an MVP. And only later, and only sometimes, do we iterate to make improvements. Data is hard to find, and speaking from experience, when you find a large cache of usable data, you tend to want to use it. The problem is that this data is not always representative and as diverse as the ultimate intended use case. Looking to build a French speech recognition model for use in Quebec, I'll tell you, it's pretty hard to find lots of high-quality training data. If you do, it may come from only a few sources, like television broadcasts, earnings calls, podcasts, university lectures, which often have limited representation in terms of demographics, socioeconomic backgrounds, and other traits. To be clear, these all represent vocal outputs from industries that are historically dominated by white upper and middle class males. So they are overrepresented, or easy to overrepresent in this example. Second step is assuming the data isn't already transcribed. And by the way, if it was already transcribed, then everyone else in the industry would be using it too, and you wouldn't have any differentiation. So now you have to transcribe it with as much accuracy as possible. Now is when dialects, accents, and other confounding factors can interact positively or negatively with the biases of whomever you hire to generate the training transcript. And again, bias is introduced. Finally, third step, you have to build a system that's ultimately going to be deployed. You have developers making decisions, and not all of whom are conversant in the intricacies of the French-Canadian language, or the difference between Romanian and Latvian languages, or simplified Mandarin compared to traditional Mandarin. You get the picture. And yet, these developers are tasked with building a system that's suitable for use in a real-world environment. If there was a lack of diversity in the sourcing and training data, step one, you can bet that there's most likely a lack of diversity in the test set as well. Because of these challenges, we need to up-level our thinking. We need to not be thinking about garbage in, garbage out. Rather, we need to now be thinking about bias in, bias out. So the consequences, well, they can be quite damaging. As ASR gets deployed in hiring scenarios, if one of the groups you fall into is underrepresented in some way, whether it's accent, gender, age, your voice's acoustic tone, your speech patterns, and that list goes on, you may not get past that initial AI-powered interview screen. Your testimony in court may not be accurately captured. Your order at the drive-through fast food joint may tend to be wrong more often. As AI becomes more ubiquitous, you will be increasingly misunderstood, which is dehumanizing. A Stanford study found that 5 leading ASR engines, RevAI was not part of this study, perform significantly worse on African American vernacular English than on white English. They found that the average word error rate across these 5 services that they measured was nearly double for audio samples of black speakers compared to white speakers. Another example, an Irish native recently was denied citizenship in Australia after failing an English speaking test, which is clearly a false positive or false negative, depending on if you're a glass half empty, half full type of person. But there is some promise. It sounds bleak, but there's promise. I'm not going to claim that we've solved it, but we've found some very promising techniques for mitigating these problems. We're fortunate at RevAI to be comparatively significantly better than other ASR vendors out there. Like I said before, our work is not done. There's a long way to go, but let me tell you what we've observed. We worked with one of our customers, HireVue, to analyze our platform RevAI against other major ASR providers in the space. It was an independent analysis where HireVue used 800 audio clips, varying in length between 1 minute and 5 minutes, and which were divided more or less equally, at least 200 clips each, across different ethnic groups that they labeled: white, black, Hispanic, and Asian. They also divided these samples by age, over the age of 40, under the age of 40, and male versus female. Our Rev.com business, powered by our diverse group of Revers, provided the ground truth reference. And our RevAI ASR engine was one of the few candidate engines that were tested by our partner HireVue. The test was initially conducted 14 months ago, but it was just refreshed last week. And the reason they did that is that we have a new next generation model that's in beta testing now. We have Rev 1 and Rev 2. That Rev 1 represents our production model deployed today. Rev 2 is our model that's in beta, and you'll see both of those data sets in just a moment. We see, and you will see too, that there's really some exciting promise in this new enhanced model. So let's get into some data. First off, I want to just say this is a word error rate plot. I want to describe what word error rate is. You take the number of insertions, which is adding words to a transcript that should not be there, deletions, which is removing words from a transcript that should have been there, omitting words, and substitutions is getting a word transcribed incorrectly. So the incorrect additions, the incorrect omissions, and the incorrect modifications are your errors. If you divide that by the total number of words, you get a word error rate. So I want to also hit home, because this is an error rate, a lower score is better. It's kind of the inverse of accuracy. 0 error is 100% accuracy. What we see here is a comparison on gender, male versus female, across Google, Amazon. Our production model that was deployed as of 14 months ago, and our new model, Rev 2. What you can see is that in all 4 of these models, they all perform better on females than on males. Most importantly, this shows a stark improvement. I think what stands out to me is the differential between Rev 1 and Google and Amazon, and the fact that Rev 2 is even further, has improved further upon Rev 1. Next, let's look at some samples broken down by ethnic groups. Again, these are samples labeled by our partner, HireVue, across labels that, groupings that they labeled Asian, Black, Hispanic, and White. A few interesting things to note here. First off, all engines performed best on the samples labeled for white speakers, and they all performed worst on the samples labeled as Black speakers. The fact that these data points are not all on top of each other, that they're not entirely coincident, that's a visualization of ethnic bias. It exists in all of these engines. What you want to see is them as clustered as possible, as close together as possible, and again, lower is better. So we're really happy with the results that show that our latest engine places our worst performing ethnic group even better than our competitor Google's best performing ethnic group. Again, there's still work to be done, but we're showing some very exciting progress. Finally, I want to look at, show you some data on accents based on country of origin. So this test was based on, all of the tests were based on the English language. But now it was compared to English as spoken by natives of the different countries that you see listed on the x-axis. What you can see here, the green scatter plot, Rev 1.0, our current production model, outperforms Google and Amazon for all countries tested. What's really exciting is that our next generation model is uniformly and significantly better than even that. So let me wrap up with some bold and prescriptive statements. First off, I have a top recommendation, and that is to prioritize diverse training data. The one reason for that is that your training data will likely be partitioned into the set that you use for training, and you'll set some aside so that you can use it for testing, independent testing later. And the fact is, if you have a really diverse training set as an input, you're solving two of the three problems that I mentioned before. You're solving the diversity in your training set, and you're empowering your developers with the tools and visibility so they're not flying blind to when they're evaluating whether what they're building is fair, equitable, and responsible. Related to that, we have found that generating real-world data is far superior to buying or trying to buy a diverse data set. By using real-world data, your system organically captures new words, accents, and other trends. It's near impossible to write down what an ideally diverse data set looks like. So having a customer's real data is the most natural and self-correcting way to train an AI model. Next, make sure that your data refinement and ground truth is derived from a diverse and reliable source. We have found that our 60,000 revers they are a very strong source of diverse and reliable data. By the way, as of today, you can place orders for both our Rever ecosystem as well as our AI-powered ASR solution from the Rev AI API. So excited to announce that. Third, test, refine, listen, invest, repeat. This is the missing middle. AI is here, but it's not a complete solution yet. The missing middle, it is real, and we're in the wave. We are in it where humans and machines are working together, and they're working to improve one another. At Rev, we've seen the fruits of how this approach can make both better. Remember when I mentioned that our AI powers our Revers to be more efficient, and our Revers provide high-quality, accurate, diverse transcripts to train our AI. That is the missing middle. and it has shown to be fruitful for us. Finally, if you use ASR in your business, and if you care about quality and bias, which you should, and which we do, please come talk to us. We're at booth number 345, right outside. We're happy to talk. And with that, I would like to thank you, and have a great conference. Have a happy New Year, and we'll talk to you soon.